In this video, I will build a molecular representation of hexane-3,4-dione using the Snatoms kit. I will show you the different atoms and bonds that compose the molecule, in addition to pointing out the different functional groups present and molecular geometries. The molecular formula of hexane-3,4-dione is C6H10O2, and it has 2 degrees of unsaturation that correspond to the 2 pi bonds present in the structure. To build this molecule, I will use the black spheres to represent the carbon atoms that will compose the carbon chain. The white spheres will represent the hydrogen atoms. Oxygen will be red, and these gray structures will represent the 2 pi bonds present. A pi bond is a type of covalent bond formed by the side-to-side overlap of atomic orbitals. They are commonly found in double and triple bonds in organic molecules. Let's begin. The first thing I will do is build a methyl group. A methyl group is a carbon with 3 hydrogens attached to it. Next, I will attach a carbon with 2 hydrogens, which is called a methylene group. Next, I will attach another carbon, but this time it will be attached to an oxygen atom through the use of a pi bond. This is called a carbonyl group. Now, I will grab another carbon to add to our carbon chain and attach another carbonyl group, which will consist of a carbon double bonded to an oxygen. Now, I will add the 5th carbon, which will have 2 hydrogens attached to it, meaning it's a methylene group. And lastly, I will attach our last carbon, which will be the same as the one we built in the beginning, and will have 3 hydrogens attached to it, meaning it's a methyl group. The main functional group present in this molecule is the ketone group, consisting of a carbonyl bonded to 2 carbon atoms. The ketones are located at carbon's atom 3 and 4. Additionally, it also contains an alkane chain, which are the 6 carbon atoms bonded to each other through single or sigma bonds. In this molecule, there are 17 sigma bonds found bonding each of the hydrogens to the carbons, meaning there are 10 sigma bonds bonding each of the hydrogens to a carbon. Additionally, there are sigma bonds found bonding the carbons to each other in the carbon chain. There are also sigma bonds located on each of the carbonyl groups, or each on the double bonds. And lastly, there are pi bonds found in the double bonds of the carbonyl groups. So 1 pi bond and the other pi bond. In this molecule, the molecular geometries present are tetrahedral for carbon atoms 1, 2, 5, and 6, meaning they are sp3 hybridized and have a bond angle of approximately 109.5 degrees. And the central carbonyl carbons at positions 3 and 4 have a trigonal planar geometry due to the presence of 3 groups bonded to them, 2 carbons and 1 oxygen atom, and no lone pairs of electrons. The bond angle is approximately 120 degrees around the carbonyl carbons. To name this molecule using the IUPAC nomenclature, we do it as follows. First, we identify the parent chain, which in this case it contains 6 carbon chains, therefore hexane corresponds to the main backbone, so carbon 1, 2, 3, 4, 5, and 6. Next, we identify and name the functional groups. In this compound, since there are 2 ketone functional groups located at carbons 4 and 3, the presence of these functional groups is indicated by the suffix dione because there are 2 ketones, but if there was only 1 ketone, the suffix would be just 1. And now if we put it all together, we know that the parent chain is hexane because there are 6 carbons, so hexane. Then there are 2 ketone functional groups present at position 3 and 4 along the carbon chain. and therefore the compound is named hexane-3,4-dione. die because there are two ketones.
Thank you for watching this video. I hope it was helpful in identifying hexane 3,4-dione and its characteristics.